the previous lesson, I told you about some of my inspirations. In this lesson, I'll go more in-depth into the teachings of Joseph Albers and Johannes Itten, two of the most important instructors in the history of art and design education. Joseph Albers was a student and an instructor at the Bauhaus. In the mid-1930s, he and his wife, Annie Albers, emigrated to the United States, and they taught at Black Mountain College, an experimental art school in North Carolina. After Black Mountain College, Albers taught at Yale School of Art, where he developed many of the assignments that are featured in Interaction of Color. In addition to teaching, Albers was a painter, a poet, a photographer, and a graphic designer. This is one of his album covers back here that he did in the early 60s. As an artist, Albers is best known as a painter, and in particular, his Homage to the Square series. His Homage to the Square paintings are beautifully documented in this book, Formulation and Articulation. These are two beautiful examples of his Homage to the Square paintings reproduced in this book. And they both show what he was interested in, which is color interaction. And as you look at these paintings, you can begin to see a little bit of this idea of colors that seem to emerge and colors that seem to recede into the two-dimensional picture plane. And as we go through the book, we'll see other examples of his work, not just Homage to the Square, but other things that he was interested in, like these beautiful paintings here of these folded shapes. Albers was very interested in space illusion, and so most of his work has that aspect to it. These drawings in particular really get that sensation of space illusion. It's hard to tell what parts are receding, which parts are advancing. In this piece, you can really see the influence of the Bauhaus. The negative space is really articulated. In fact, the negative space here is the dominant part of the composition, the focal point. More beautiful homage to the square paintings. You might notice that the palette is the same on both of these paintings. The same colors are used in both paintings, but they're used in different ways, and so the colors seem to emerge and recede in different amounts. This motif goes all the way back to the Bauhaus. Albers was initially a glass artist, and a lot of his work was produced in glass, including some of these compositions. Here they're just reproduced as line compositions. This piece in particular goes all the way back to the Bauhaus. And a version of this is actually reproduced as a mural in what used to be the Pan Am building in New York City. Now it's the MetLife building. So if you're walking through Grand Central Station, you can take a little detour and see a mural based on this design concept. Here you can see Albers working with grayscale, but still intent on producing that sensation of the colors that seem to advance and colors that recede, and this whole idea of space illusion. Which parts of the composition seem to be coming toward us and which parts are going away. These paintings, which are not homage to the square paintings, is something a little bit different, almost like a stereoscopic effect, and sometimes they produce what are called afterimages, illusions of rectangles that seem to bounce around the picture plane. Here you see the same composition produced first as line and then with form. And notice how the form, some of the forms are articulated with very crisp edges, and some edges are very rough, very complex. Again, that same composition reproduced here in color. More variations of homage to the square. So here again, we have these compositions that are really stereoscopic and producing afterimages. I can start to see them a little bit. This happens quite a bit when you're working with complementary colors, colors that are opposite each other on the color wheel, like orange and blue. And finally, the last thing I'll show you in this book is this beautiful series of red compositions, all homage to the squares. One of the things that Albers talks about in his teaching is the idea that we all have a different idea of what red is. And oftentimes he would experiment with this, asking his students to bring samples of whatever they think of as red. And here we see all these different reds: bright reds, dark reds, light reds, vivid reds, dull reds. Albers was very interested in this idea of how we identify color and how we relate to it. He would talk about the concept of actual color and factual color. Actual color being what we see, and factual color being what we recognize as the scientific name of a color. The book that Joseph Albers is most famous for is Interaction of Color, a collection of his color experiments that he perfected while he was teaching at Yale. When we open the book, we immediately see these beautiful color experiments. They're all meant to produce the effect of colors looking as if they're different on different grounds. This book has these little dots down in the corner that Albers has put there to tell us how to look at the work. When we look at this first composition, and when I showed this to students, I always ask them the same question: how many colors do you see? Most people are going to say 3 because they know the experiment. But when we really look at this, we actually see 4 different colors: 1, 2, 3, and 4. These 2 colors are actually the same, but they appear different on different kinds of grounds. The purple on this side is dark, the green on this side is light. So each of those colors has a different effect on the inside color. Albers calls this the relativity of color, and he says that in art and design, color is the most relative medium. It's always changing, it's always deceiving us. In this experiment, Albers says, make 5 colors look like 6. And all of his color experiments really have that idea in mind of trying to create an illusion of some kind. So when we look at this grouping of colors, we see 1, 2, 3, 4, 5, 6 colors. Here we have fairly vivid orange, a very vivid yellow, a dark blue, and a very vivid, very intense kind of blue-green, almost a cyan color. And then these 2 small squares here, one is kind of a dull orange, not as vivid as this orange. And then on the other side, we have a square that's very dull and dark. And actually looking a little bit blue too, a little bit. And when we lift up this flap, we see that it's actually the same color. So 5 colors, 1, 2, 3, 4, 5, can look like 6. 1, 2, 3, 4, 5, 6. Based on the grounds. Another great example from this book, which shows a window with 2 gray squares, rectangles, on the inside. They appear the same. And when we pick up the window, we see that those 2 gray squares are on different grounds, again, a light and a dark ground. And we see that this square, rectangle, looks light, and this one looks dark. So now we can start to think about what's actually going on. Now we can see what's really going on. The background color is affecting the inside color by subtracting its essential qualities. In this case, the light green is subtracting its lightness from the rectangle, making it look darker. In this case, the dark color is subtracting its darkness, making the rectangle look lighter. In fact, they're the same physical color, but we see them differently. So Albers says this is what we call factual color, and this is what we call actual color. It's actually what we see. Again, same color on different grounds, producing very different color effects. Here we see the same green grid pattern used on 2 different grounds. On one side, the green looks light, on the other side it looks dark. And on one side it looks more of a yellow-green, on the other side more of a blue-green. So this is color relativity. Color is always relative to its background. It shifts. If you were to do a Google search for Albers' color illusion, you'd probably see this image. It's one of his most famous. The two color rectangles are very different in hue, meaning one is pink and one is green. They're actually complementary colors, colors that are opposite each other on the color wheel. And then there's an X on the inside of each of these colors. And that X is actually connected at the bottom, meaning that this X and this X are actually the same color, actually, meaning what we see. But when we look at this X, it looks darker, and this one looks lighter. And in fact, if you stare right in the center of this composition for, say, 5 seconds, this X starts to look pink, like this color. This X starts to look green, like this color. Now that has to do with color relativity. The background is affecting the way we perceive these X's. And going back to that other concept of subtraction, the background is subtracting its essential qualities from that X to produce that color illusion. So in this case, the green subtracts its darkness, makes the X look lighter. In this case, the pink subtracts its lightness, makes the X look darker. And the green is subtracting its greenness, making the X look more pink or red. Here, the pink or red is subtracting its redness, making the X look more green. Jumping ahead in interaction of color, we get to another essential color experiment that Albers taught his students. He calls this the illusion of transparency, and sometimes he calls it transparence and space illusion. And this is a great example. These are 3 colors that are meant to create the illusion of transparency. There's no actual transparency here. We have a dark gray or a black, a medium gray, and this lighter gray over here. And it appears that this rectangle of gray is overlapping this darker rectangle and producing this color, this middle color. But in fact, it's 3 different colors meant to suggest an illusion. This is another way for Albers to teach us about how color is relative and how we basically will try to see things that we want to see, which is transparency. We're used to seeing transparent materials create this effect. But in reality, what we're really seeing here is just an illusion of transparency. Here's another good example of the illusion of transparency. And in this case, the background color is also having an effect on how we perceive this illusion. So 1, 2, 3, 4 different colors producing the sensation of colors seemingly to be transparent, as if they're transparent film. Now, some of you will see this rectangle overlapping this rectangle. Some of you might see this rectangle overlapping this rectangle, as if they're transparent. The last illusion of transparency example I'll show you out of this book is this, what we call the ladder. It's like a ladder that you would climb up with rungs. It's really interesting to look at this. So the background color, the gray, is very consistent all the way around. The yellow is consistent all the way through here. And then these squares of red that are on the outside of the yellow band are all the same color. The only thing that changes are the inside colors here. And they get progressively lighter, mixed with the yellow, to produce that sensation that they're actually receding, going back in space. So on a 2-dimensional surface, we now see that transparency can affect space illusion.